Magnetic property. Now after studying the solids and classifying the solids on the basis of the electrical property, now we have to study magnetic property. In this basically we again try to classify the solids on the basis of their magnetic property. Now solids on the basis of magnetic property are mainly of 5 types. The first category includes the diamagnetic solids. These are the solids which contains all paired electrons, and once they are placed in external magnetic field they get repelled by it. They get repelled because their electrons, all electrons are paired. We can represent it electronically like this. So all electrons are paired in this, and the example includes water, sodium chloride, benzene. We can have rubber, plastic like this. All are diamagnetic solids. Let us move to the second category, paramagnetic solids. These are those solids which when placed in external magnetic field gets feebly attracted because they contains few unpaired electrons and rest of their electrons are paired. It's almost is like this. Example includes your oxygen is paramagnetic, sulfur S2 in the gaseous state is paramagnetic, cupric ions, ferric ions, chromium 3 plus all are the paramagnetic in nature. Third category includes ferromagnetic solids. They are the solids which when placed in external magnetic field get strongly attracted, and even they can retain this magnetism even after the removal of the external magnetic field. Now because they have many unpaired electron which gets aligned all in one direction under the influence of the external magnetic field. The example includes iron, cobalt, nickel, CrO2 etc. which are ferromagnetic solids. The fourth category of solids on the basis of their magnetic property are antiferromagnetic solids. Now as the name suggests, they are exactly opposite to the ferromagnetic solids. Now how? Now they have many unpaired electrons, but in spite of having many unpaired electrons, when they are placed in external magnetic field, they behave like diamagnetic solids. The reason is because all their paired electrons are aligned opposite to each other. As a result, their magnetic moments gets cancelled. So they behave like diamagnetic solids in external magnetic field. And the example is MnO. Then the last category of the solids on the basis of magnetic property are ferrimagnetic solids. These are the solids which, again as the name suggests, very similar to the ferromagnetic one. These are the solids which when placed in external magnetic field, they behave like paramagnetic solids. Now they have many unpaired electrons, but in spite of having many unpaired electrons, they are behaving like paramagnetic solids. The reason is because that most of their electrons are aligned opposite to each other. Only few of them are aligned in one direction. Otherwise most of them are opposite to each other. So examples includes the Fe3O4, magnetite or ferrites, which also includes Mg, Fe2O4 or Zn, Fe2O4 etc. types of solids. So these are ferrimagnetic solids, and this is the 4-5 categories we have of the solids on the basis of their magnetic property. Also don't forget, we can also find out the magnetic moment of any solid on the magnetic moment by using spin only formula, which includes n into n plus 2, and the unit is Bohr magneton, where n is the number of unpaired electrons we can have in that particular solid. So this is what we have, the different solids on the basis of their magnetic property.